Start recording. Thank you. So here we have check 5 and check 6. So if we console log check 5 and we call it with our array. So now check will get the array here and it will run the filter function against the array and returns a new array and it will display it here, obviously. Clear? Make sense or confused?
Confused.
Yeah.
Now the 5.
Let's just check. We have an array with 200 elements.
Yeah.
Which is the element that accept or divisible by 5. Let's do another console.log. Check 6 and call it with our array. So here we have 6, 12, 18, 24, 30, 36, all the elements that accept 6 or divided by 6. 5, 10, 50, okay. So our implementation is correct, or it's not mine. I just copied the code, but fair enough. So let's try to kind of break the code apart and understand what's going on. So check is returning an array, okay, and the array will get displayed by the console of the log. Okay, console.log will display the array. So we are getting the array from check 5. Okay, check 5 is divisible by factory 5, which is this one. So when we invoke this function, we give it a number like 5 or 6. It will create a function. So every time we call this function, we create a new function inside it. Okay, let's say here console.log creating. It's creating here and creating here. So every time you are calling this function, the factory function, it will run through this code and it will create a new function. So every time calling this function, it will create a new function inside it. It's like a whole small JavaScript like code inside it. It's like when you run for example this code, it will create this function. When you refresh the browser, it will create this function again. So imagine this, the same thing is happening inside this function. Every time you call it, we will create check again because we are declaring something inside it. Okay, and we are returning it. So here check here and check here are not the same thing. They contain the same code, but they are not the same thing. They are two separate functions because we are creating a function on the fly. Every time you call a function, inside it we create something. It's like having a burger or something. It's like the same burger, looks the same, but it's not the same one. Because every time someone requests a burger, you create a burger for him. It's the same like cheeseburger or something. But technically it's not the same. Looks the same. This function is the same. It contains the same code, but it's not the same function because we are creating a new one. Yeah.
Just like in this example, we are creating the function on the fly.
Yeah.
So what's the difference, if we take this function out?
Yeah, yeah. That's really good. Like, let's put this function outside. Okay. And let's just return check here, or let's return. Let's do function test. I will just name it test. Return check with the array here. So I'm changing the interface with the array here. Okay. But there is only one thing. I cannot move the function outside. You know why? Because the function needs this number z. So if I move it outside, how this function could get the number z? I can do something. I can pass the number z here and pass it here. I can do this. Valid. Did you get me?
Yeah. We are passing two arguments.
Yeah, exactly. So now this function check is the same, but I'm creating another function called test now inside because I need to wrap the check because the check is generic. I cannot just like return check because checks need two parameters or two arguments, the array and the number. So I cannot just return it. I need to create a custom function. So the code from outside, this code, when you call check5 or check6, it's not the same thing. You are calling a different function. If I will return the same check, it will be not like different, it will be the same one. So we need to kind of differentiate check by passing different parameters. That's how function works. They are like the same functions, but you customize the function by passing different like parameters and arguments to it. Make sense? I'll just get back to the old implementation.
I understand the logic of the function,
Yeah.
but I have problem understanding some this like mathematics. Like if someone tells me to get something and
What do you mean?
I'm stuck in
What do you mean? What?
mathematics.
Same.
Yeah.
No one is good at mathematics. They are just lying. They are just lying and solving lot of exercises. No one is good. It's too
So
hard.
you
Man.
can memorize this stuff like it's always like this. And
What do you mean by like this one? Like num?
Yeah, for example, like
But this is not important. This is implementation details. If
Yeah.
someone will tell me to do this, I would go take it from Google.
yeah,
I will not
that's
solve it
what
by
I
myself.
mean.
If you told me that compute the factory of number x divided by, I will just go to Google and write the same thing.
Yeah.
It's not what we are. There is generic stuff and there is implementation details. This is implementation details. For example, you can tell me like return the numbers that are smaller than or less than 5 or more than 5. So you use like the greater than or less than operators. This is implementation details. What we are trying to understand here is not understanding if a number is divided, like can be divided by 5 or something. It's functions and closures and how to return functions. It doesn't matter. Like this is Z or num. It doesn't matter. Yeah, exactly. It can be like, I don't know, getting stuff from Facebook. You can like build an application where you get stuff from Facebook. You get pages from Facebook, and you show just the pages that they have like, I don't know, likes more than 1,000 or something. So we don't need to have like kind of numbers and stuff. Could be like fetching stuff from Facebook or YouTube, or let's say you want to build like YouTube player or something and show only the videos with views more than 1 million. So you will have like kind of views count. And you will check like views count more than 1 million here.
I wouldn't calculate the views.
Yeah, exactly. Yeah, this kind of stuff are not really like. So don't really like need to understand two things at the same time. We are here to understand closure. I have a lot of problems with mathematics, but it's not really like.
So this is closure, and I ask. Closure is somewhat appears to be somewhat contradictory to to global scope or scope. I should say. I thought.
Well, closure and scope are two different concepts.
Okay.
What we mean by scope is like stuff that you have access to.
Yeah.
If you have access to something, that's your scope.
But closure seems to contradict it. So I thought.
Closure is like closing over something.
Like closing something.
Yeah, exactly. So let's say I don't know how to find. This is like really something proper to JavaScript. You will not find it like almost anywhere in other programming languages. It's proper to JavaScript. But let's say that we have like I don't know. Let's say we have rooms. Each like kind of person or something has its own room. So your scope is the room.
Yeah.
You know your room.
Yeah.
There is stuff like variables in your room. You know them. But other people's room, you don't know. Exactly. It's like another function.
Okay.
It's like each function is a room, or you are the function, and there is like room, which is your variables inside.
Yeah.
So you have the room. Okay? But another room, another function, you don't know what's inside. So if there is a variable called x inside another function, it's like inside another room.
Yeah.
You can't access it. Even if it's there, you don't know even if it's there. Okay? You don't have the permission to do that. This is scoping, which means like you are scoped to some stuff. Yeah. You are kind of closing over some stuff. But let's imagine that closer is like sharing space. It's like the living room.
Yeah.
Or let's like I don't know, like the kitchen. Let's say you have rooms and you have like shared kitchen. So you are closing over the kitchen, even that it's not defined like in your room or something, but you are closing over it. You have access to it, even that it's not yours. You didn't define it. Ish, something like that. So that's kind of the difference between scope and closure. Okay. Scope is like some reserved place you have access to. Yeah. But closure is like closing over someone else's space or someone else think. We can really like.
So is it not the general scope?
That's what I was
Yeah.
saying.
The closure.
What do you mean?
Is it the general scope? Because
We can have like scope nested inside the scope, nested inside scope, nested inside scope. So there is no general and private scope.
But right here, for
they give.
Let's see an example. That's really better. Let's say I have a function called test.
Can you please zoom in? Sorry.
Yeah. I'm sorry. Just tell me if there is a problem with Zoom or something. Can you see like this? Is it better or I need more? Good like this. So let's say we have test, and test will do console.log. Let's say 5. No, not 5. Let's say. Yeah, X. I really don't like naming variable X. Oh, sorry. Okay. Var X. Okay.
I would think that we shouldn't have access to the global scope there. Is that correct?
We have access to the global scope.
Okay. Because I thought function was its own room, and then the global
Exactly,
scope
but the function is like so there is like a misconception about JavaScript which is really famous. So there is like the definition of function and invoking a function.
Okay.
Okay, so when you define a function, the function will have a link to the place where it was defined. Okay, so the function test here, it was defined in the global like kind of scope or the global like file.
Mm-hmm.
It will have a link here. It will have like kind of link it to the window global main
Whatever.
something. The global thing, not a function specific thing. So function has kind of link to where it was defined, not where is. For example, if we have a function here, test2, and we do test. So this function was invoked inside another function. But the link that this function has, it's to the main scope because it was defined there. So this is really famous misconception. You need to kind of differentiate between where a function was defined and where you are calling the function. Okay, that's really create a big like kind of misunderstood. Okay. Yeah, really big. So this function was defined here in test. So if we will go to the browser, let's say yeah, I will call test2. I will call test2. Test2 will call test1 or test, and it will obviously show something. I don't know, maybe. But there is like this debugger, like kind of keyword. It will stop the execution of the code, and it will show me everything here. So there is the concept of call stack. You know what a call stack means? It's like every time you call a function, you put it in a stack. A stack means something you can put at the top, and you can remove it. So if we have like a stack here, we put the first element, the second element, the third element, the fourth element. If we want to remove something, we cannot go like under or something. We need to remove the last element. So we need to, so this is fit 1, 2, 3, 4. I cannot remove 1, 2, 3. I need to remove 4. After that 3, after that 2. This is like a stack. And so here we have test2, test1. This is our stack in the browser, in Chrome. Because we call the function, we have like anonymous, which is main. Anonymous, our file called main.js. Okay? So it's like the main scope. It's like the entry in the call stack. After that, we call the function called test2. So it's here, test2. After that, inside test2, we call test. And now we are here. Okay? We can see, so this is the call stack. We can see the scope. We have local. The local this. It doesn't matter. We have scripts. Because it's script based, but it's just this array. We can access it from the script because it's global. And we have like this global window, which is the big thing. We don't have X because X is inside global. Because window.x and X is the same thing. If you define something globally, it will be related to the window. Okay? So this function, if we will define another const var inside test2. Test2. Let's name it test1, just to. Okay. I will refresh again. So now in the local scope, I have two stuff. I have the this, and I have the var inside test1. It's my local scope because I defined this variable. But I have access to test2, but it's not showing as a local scope thing. Okay? Because I didn't define it. It's not my local scope.
Local scope is for the function.
Yeah, for like the space that I've created.
Yeah.
It's my function. Okay? So let's do something now, which is kind of crazy. Let's console.log test2 inside test1. That's kind of crazy because we are like showing a variable or printing a variable that it's defined in another function. But this function is calling me inside it. It's kind of crazy. That's right. Yeah, but we will remove this because it's stopping the execution. Error. Reference error. So variable, it's not defined. But how? Even the test2, it's defining this variable and calling this function. So this function is called after like the definition of this variable. So this function should have like access to that variable. Why not? This function is not able to access this variable.
Because this one is scope to this function.
Yes, but this function is calling test1 inside it.
Yeah, but it
Yeah.
doesn't have-
But-
in the global
Because it was
No, I need more precise. Like
defined before.
it's because of this. It's because of this. The thing that I wrote here. Because this function has its own scope and closing over where it was defined. So this function is linked to the global like thing. So even if we are calling it here, calling it anywhere else, it doesn't matter. What matters, this function has two things. It has its own scope and the scope where it was defined, or closing where it was defined. Okay, so it was defined in the global.
So if I put it inside that,
So if we do this, it's showing 5, but it's not showing var inside test2. Why? Because this function, it's scoping its own
it's on.
scope and also closing over the scope where it was defined, which is the global scope. So it has access to X and stuff. But
Is it fair to say, is it accurate to say that it can always, a function can always search upwards into its parent, but it can't search down into a sibling?
no, yeah, precisely. That's exactly what's happening.
Okay.
So a function is referring to the parent where it was defined. What I'm saying about it, because there's a misconception. Some people define the parent by where it was called,
Yeah.
where it was invoked. That's not the case. The parent is not who called me. The parent is who defined me. Let's remember this. So if someone is talking with you, he's not your parent. Your parent is who give like birth to you. You know, that's the thing. So exactly, when I was defined, when I kind of was created. That's my parent. And not when someone randomly called me. Is kind of, and I'm linked to the parent, not to where I was defined or where I was called, invoked. Yeah, that's kind of a good example. So this is var inside. So I don't have access to, but if I will move this function, the definition, the creation inside this. I have access to 5, and also I have access to why? Because test 1 is linked to the where it was defined, and it was defined in test 2. So it has access to everything inside test 2, including var inside test 2.
Yeah.
But also, it has access to the parent of test 2, because I'm linked to my parent, and my parent is linked to his parent. So I have also a link to the grandparent, kind of. So
this is a closure now, right?
Yeah, it's a closure, because we are closing over something.
Yeah, that's
Okay, so the function inside function.
Yeah.
This is the closure.
Not really. Closure is like when you close over a variable, so you can even use it that it's not defined there.
It's not defined anywhere.
Yeah. For example, let's say
not second.
I will return test 1. I will return test 1. I will not call it.
Mm-hmm.
So here test 1 will return a function. Okay? I will call it. Test 2 is returning a function. Test 1. Make sense? So instead of calling the function, I just return it.
Okay.
I used to call the test 1 here.
Mm-hmm.
Instead of calling, I just return it. So I will call it somewhere else. Okay? So now it's still working properly. Even that the call of test 1 is done. So we run like test 2 here. Test 2 will run, and it will create this function, it will create this variable, and it will return test 1. So running test 2 is done. We are not running test 2 anymore. And this variable is scoped, or it's local to test 2. So it should be gone. It should disappear, because test 2 is already disappeared. But no, we can call T1 after that, and we still have access to test 2. Why? Because the function is kind of closing over it, and it's saying, I need this variable, you cannot remove it. Kind of makes sense? Because like technically, this variable, if I will not return this variable will be just like removed after running this function. Because if you do like console.log var inside test 2, okay, this function can print this function. It can print the var inside test 2. It can like display it, but we cannot display it here. Let's check. Var inside test 2 is not defined. So this variable is not defined. But when I call this function t, it's defined. That's weird.
Okay, if I call it after calling it the function.
What do you mean? Even it's not about like random positioning or something. It will be always var test. Even that the function could print test 2, but we cannot print test 2 here. Why? Because this function, it's closing over this scope.
Mm-hmm.
So JavaScript will notice that, oh, this variable is used by this function, and I'm returning this function, so I will use it somewhere else. So I should keep track of this variable, or I will kind of provide this variable to this function because it needs it outside. But when I try to print this variable here, it will say, what? There is no such a variable, because you didn't close over it.
Mm-hmm.
Is it clear? Somehow?
Then I need to use it like you see, like
practice.
I need to use
Yeah,
it.
of course, but I'm just trying to get like the principle,
Yeah,
you know?
the idea,
Because
yeah,
that's
the idea.
yeah.
So that closure, important. That closure means
I said closing the variable.
Precisely. It's like creating my own one, even that technically I don't have access to this.
There is no access from the outside.
No.
To that variable.
But I have access. Even the
Yeah.
t is in the outside world. The function t is in the outside world, but still has access to inside too, because it was defined there, and it has a link. So this function, it's linked not to the window global main, but to the test2. We said it was linked to window global main because it was defined there. But once we moved it to test2, it's now linked to test2 scope.
Test2 is like
The function
the
test2.
global for test1.
Precisely.
Yeah.
You don't know like what's global. What's global for you is the outside world.
Yeah.
Exactly. It's like for us, the earth is global. But there's so much stuff like outside of the earth. But for us, no, the earth is global. And if you can go outside of the earth, you will see the galaxy, like stuff like that. So you always define like what you can access as a global. Clear? So, is it also clear for you? Okay. Just to get like an idea of what closer means specifically. It's like closing. I don't have access to a variable, but I can access it just because I could define my function inside it. Clear? I will pass this code in the... Okay. So you can just try to get like... but I need to edit this. Okay, it's linked to test2 scope. Is it kind of clear? So the scope is what I have access to. Closer is like closing over something that technically I don't have access to, but because of a hack or I was defined it somewhere, so I have the chance to. Okay.
Now, why do we do this?
Yes, it's really important, super important. You will see. So I will remove this code. Yeah. So we are here now. We have check. We have creating, filter, and stuff like that. We are returning check. So you understand this example? Kind of makes sense? So can you see here if we have a closer or not? That's really the worst place ever. No, it's not. I'm just. You can just. Yeah, but it's not really like important. It's good. So can you see here if we have a closer or not?
Yeah.
Give me like where to say we have a closer there or there here.
Check 5.
Check 5 is closing over one thing, which is exactly. Even that it's not defined anymore. When we run this function, z, the parameter will just disappear. But because I've mentioned it here, it's like JavaScript is checking. Do you need this variable anymore? Do you need it? Yeah, you need it. Okay, I will keep it for you. This kind of thinking. So now the function 5 is closing over the parameter z. So we can use it even that it's not there anymore. I cannot print it. I cannot have access it like anymore. but just because of that, I can. Kind of make sense? Yeah, of course. Like even me, I'm still confused about a lot of stuff. Like this is JavaScript. It's so weird. Like the creator of JavaScript have created JavaScript in 10 days. He created the language in 10 days, the whole language in 10 days. It was like they were like saying to him, "Just do it, please, fast." This is why it's so weird. Okay, so don't really blame yourself or anything. It's so weird. And hopefully, like in job interviews and stuff, they don't need you to know like every like small details about it because you will learn by experience. But what's really like important is just to keep it up and keep learning. You know, when you see something wrong, you need to kind of investigate what is going wrong. That's the thing that they are looking for. People who are angry to kind of learn. Okay, so let's do something else.
The best part of this assignment was we were just passing we were just looking for one word, one integer that can tell us how many are divided using. For example, 3 is divisible by how many of those inside our group. So now we're giving an array of 30. So we can give us for one how many is divisible by 1,000.
Yeah. I couldn't understand you really well, but I will just.
Yeah, it's it's 1,500. So 1 is divisible 1,000 times.
Yeah.
And 2 is divisible 500 times.
Yeah.
Means the array. It's testing.
Okay, so let's try to kind of imagine. You get a number, for example, 1. You check it inside. You use the function that we created, and you count.
Yeah.
So 1 is 1,000 element. So you just like take the length of the array, and you say that for. Okay, let's kind of do it.
It's 1 to 30.
Okay, from 1 to 30.
Yeah.
Okay, so we have a new array now from 1 to 30.
Yeah.
So I will create a new function.
Isn't it just the length of the return?
Yeah, I think so, but I'm just trying to kind of like do it kind of more complex, like using scope and more complex. Okay, I will just ignore this. So let's say function count. Let's name it count. It will take an array, which is the from 1 to 30 or from 1 to 40 or something, and it will return a function. Okay, clear? Why you are looking at me? Did I do something wrong? Like what? What is there something wrong?
By function, not return count. Or
You cannot return the function inside. You cannot return count inside itself. It will keep repeating. For example, here we return check, not divisible by factory. Okay, so instead of doing this, I can say function. Let's say sum. I can return sum, but I can just return here on the flag. Okay, this one will take. Let's say this one will take numbers.
The reason why it doesn't really matter what you name the function inside is that the name is not visible outside of the function scope.
Yeah.
I would include.
But you should use it. You know what's good? Because if you run into like errors or something, you'll see the name of the function inside the error.
Yeah.
That's why it's good to imagine you have a lot of like anonymous functions. You don't know like what, where is like this error. That's why like name it versus like anonymous function. That's the only kind of thing. Anonymous function are kind of anonymous. You don't know them. So if you run into a trouble inside an anonymous function, you don't know where are you or what they are doing because it's anonymous. This is why I like to give like name. So here we will map over. So we will do numbers dot map. First, let's just try if let's try to call count. So enter 30. Okay, from 1 to 30. I will give it to, I will say numbers. Or okay. Now I can call.
Inside also.
Hmm?
Inside.
Oh yeah, yeah. Thank you. Now I can call numbers. After that, call it straight away. I don't need to return something. Is this kind of clear? We are calling a function and calling a function after it. Because count is returning a function.
Yeah.
So I can call it
Okay. That will execute.
inside it. So I can do this. I can put this into a function d and call d or something. But I can just do it here.
This is what called if.
No, that's another thing.
I don't understand
What?
You involve the function by the parentheses.
yeah,
What is going to return? A function.
yeah, it's going to return that let's, it's going to count to 30.
It will return just this function, the sum function. Count, it will return the sum function.
Okay.
So I will call the sum
The
function.
sum of numbers.
It doesn't matter, it's just like a function. It doesn't matter what it's doing because it's still empty. So we are mapping here.
I don't understand why you need those extra parentheses. Isn't it already being called with the parentheses around numbers?
The parentheses around numbers will call this function, count.
Yeah.
And it will return what?
It will return,
Function sum.
It will return of this function. It will not run this function. It will
Can you-
return this function.
Can just console log it?
Yeah, of course. It's a function. It's a function sum.
To return
okay.
the definition of the function.
It's like here. It's this. It's returning check, and this will return check. So we have check 5 here, and we will call check 5 here with a new array. So I can just do this and pass it the array. Did you get the idea? Because this is it's returning a function. Okay, I will try. I see some confusion. I will try to avoid that, but just
Okay,
to
you
get.
mean you could remove check 5 and add this.
Yeah, I will add the array
And
because
remove check 5.
yeah, it's like calling it here. When I call it here, so the return of this, I will put it in a variable and call it here. So I can just console log
Yeah,
this
it's
instead
like
of check
okay.
5 array. That's what I'm saying. It's like shorter. It's not good to call this function like. It's not good.
I'm
But
still not sure. I still don't understand why the second set of parentheses. Why we need those.
yeah, I see. So, what this function is returning, or what this function is returning, the count function. What's returned?
Sum.
Is it returning a function or a variable or name or what? What is?
Returning another function?
It's returning another function.
Yeah.
It's not calling another function. It's returning another function. So I can call this function again.
Yeah, but the thing is, in JavaScript, these
Parentheses. Yeah.
the word of them is to call.
Yeah, exactly. They don't
So it's
really
a
give
caller.
shit.
Like,
Yeah.
if you want to call a function, you need to put these after the name of the function.
Yeah.
But that's I get that. But we have two sets of them.
You need to call the function inside the function. That's why you add two parentheses.
Okay, that makes sense. Yeah.
Because this is returning a function. Count is returning a function.
Yeah.
I want to call that function.
Yeah.
I will add a set of parentheses here.
So the first set of parentheses
It's for calling count. The second one is for running
So
sum.
calling sum.
Okay.
Yeah.
Nice.
Yeah.
Yeah, alright. So here I will just console.log numbers dot length and array I have 30 and 1000. Kind of. Okay. Okay. So now our job is to, for each number inside the numbers array, we run the divisible factory for each number. Okay? So we will map over it, or we can reduce over it, or what we can do. The idea is for each number, so we have 1, 2, 3 until 30, we call this function with the number that we will have access to it. It's like numbers of 0, numbers of 1, numbers of 2, numbers of 3. Okay, and we call it. And that will give us an array. And we can check we can do a simple example. We can do numbers, so we can take 1. Or let's take 2. Let's take 1. 1 means 2, because it's the second element.
Yeah.
So this will create check 2. Okay. I can do the same thing. I can just call it after. I can just call it and call check inside it, because this function is returning check. So we can just call it here, and this will be the array instead of the function check. Are you okay with me doing that, or I should avoid it? Just say it here. Okay, so I will avoid it. I will avoid it. Yeah, it kind of makes sense because a lot of parentheses and numbers inside it. So I will have like check2, and I will call check2. That will return array. Array. I will call it array n. Means like array 1, array 2, array 3 until 30. And I will console.log array n dot len.
So, call check2 for the array.
Yeah, we need to call check2 with the array. Thank you. So it's 500 for 2. But this is just for the number 2. We need to do it for each number inside the numbers array, from 1 to 30. But also we need to keep kind of track of all of them. So we call it for 2, and it will give me we call it for the first number, which is 1, and I will take the array.length. We call it for the second number and take the array.length. Third number, take array.length. And we keep going on.
Can we stop here and walk with the code? Like
Yeah, of course.
how the flow
Yeah, of course.
went from
Of course.
where to where? Like
Yeah.
from
So we have numbers. That's kind of clear. It's just an array with 30 items from 1 to 30. So we count. We run the function count. Just omit this part. We just run the function count. Okay? With numbers. So this numbers will be this. It will be replaced. And we return a function inside it. That function will take an array, which is this. So until here we are just defining this function. We are not really running it.
what's this?
Array was all the way up to the top.
Yeah, it's like 1000 like element array. So we run this function. We will run this function, divisible factory, with the second number, which is 2. 1, 2. It will return a function. That function that will check with the filter.
So
This
those are a
function?
function or this one's a variable?
No, it will return a function. This is why I'm calling it here check2, because I'm not doing parentheses. If I'm doing extra parentheses here, it will return the variable. But now it's like these 5 and 6, they are returning functions, and 1 is returning function, which is this one, the check function. Okay? And I'm saying array n equal check2. So it's this function or the check function with the number 2. So it will take the array here and filter and see the rest of the division over number 2 for all the elements. Clear? And it will return an array, obviously, with the numbers that are like divisible by 2. And I will just like console.log the how many items the array contains.
Reminds me of the movie Inception.
Yeah, exactly. We are inside. Like, are we in a dream? Are we not? Yeah, exactly.
It's funny you would say that because somebody actually wrote a little program where it puts all the functions inside of the application.
And you will not, yeah,
It
get.
would lock the scopes and it would at the end give you the dialogue for the function.
That's what I mean. Not that Inception was complicated. I mean, it reminds me it's a dream inside of a
Yeah,
dream
exactly.
inside
It's
of a
like
dream.
nested stuff. Yeah, yeah, crazy,
Great movie.
but not enough. Okay, is this clear? Somehow.
Yeah.
So now we are running this code just once for the number 2. We need to run it for all the numbers. So it's like a map. It's like a loop. So we can use a map or something. But I will not use a map because the thing we need to keep track of these variables. Okay. So what was the statement? We just need to print them. We just need to print, or we need to return them, or what? Return what? We return. Return this array. Okay. Okay. Yeah. So we will use map because we are creating a new array out of the. Exactly. So we have 13 numbers. We need to return a new array with 13 numbers. So it's the same length, but instead of returning the same number, we have a flow like. Something? No, there is no pen here. I thought that it was.
Were you complaining about the open window or because of the sun?
The sun.
Okay, because it closed the window and I feel
That's
very-
not good. That's
Yeah.
not good. Yeah. The sun is better.
Yeah.
Sun is better.
Super early. Yeah.
Yeah, you can open it. I don't know.
Yeah.
Just showing this thing.
Yeah.
Yeah. It will be nice though, man. I have to remember.
Yeah, it's okay.
The guy at the Google place. No, after the here.
Oh. Yes. Yeah, it's still open.
Visa stuff. University stuff. I'm still involved in university life.
We saved your life.
Oh my boss.
Can you use paint or something like that?
What?
What? Are we?
Yeah, thank you. Thank you a lot. Thank you. So the thing is, we have an array with 1, 2. Sorry for my. This is not 2. It's like an animal or something. 3, and we have until 30. Okay. So we will create a new array out of it with numbers. I would say like n, and so a lot of numbers, different numbers. So we need to get from this array to this array. So, but we need kind of formula how we can transform this number to this number to this number. What we are doing, we have like an array from 1 to 1000. We get this number. We check how many items here are divisible by this number. And that will give us an array. Okay? We count how many items are in this array. That will give us a number, and we will put the number here. And we will keep doing this same thing for each entry inside the array.
Oh, okay.
Okay.
Make sense?
Yeah.
Okay.
And we will use map because we are mapping. Means like, for example, like, there is a really famous example of map, which is like taking triangles and like a triangle or something and converting like them to circles or squares.
Yeah.
So we are mapping. You are changing the shape. You are kind of computing something out of something else.
Will you use map
Can
and
we
push
use
afterwards?
No, I will just use map, and map will give me another way. So in each,
Yeah, for the first step.
yeah.
Map.
So I will map over this array.
Yeah, and then
And
you get
just
to
a
the map.
I will map over this array,
Mhm.
and each time I will return a number. And map will just collect these numbers in one array. I don't need to do that.
Okay, but after that, when you have to push this.
I don't need to push because I will compute something. I will run this. I will run the divisible factory function with one. It will give me an array. I will compute the length of the array using length property. After that, I will return it. So I will just return a number, and the map will jump to the second item and return a number. It will
No, I
return a
mean
number.
the last array.
The last array will be like all the numbers combined. I don't need to do that. Map function will do that.
Okay.
Because that's the thing of the map function. You will return stuff, and the map function will do its magic after that and collect all this stuff.
Okay.
Okay, it's like filter. The filter function will run in the collection and see the items that kind of make a condition or statement true, and it will collect them in one array. Map, it will be the same thing, but instead of filtering, it will just transform these numbers and collect them in one array. Okay? So
There was the question here if we could use filter as well.
Yeah, is it possible? Is it also okay to filter?
I will use filter, but why I will use filter here? Because I don't need to filter anything. Logically, do you need to filter? Logically. Do you need to filter any items? Well, we just need to compute like new values out of the same item. So we have 30 number.
Why not? Because there is 1,000 or 1 to 1,000. Then I have to.
But just one thing. We are here.
Filtering something.
Yeah, no, we are not filtering something.
We're talking about two different steps. We have used the filter before to find the divisible number.
Yeah.
And that we will maintain. But now is the next step.
Yeah. Now
And in the next step we need to do
So-
a
What we already
transformation.
filtered, then now we are going to.
Exactly. So here, I kind of so I will take the number 1 and 2 and 3. So first, I will take the number 1, and I will run the divisible factory. The divisible factory will run the filter and return a small set of the array, and I will take the length and return it. And I will do the same thing with 2, with 3, with 4, 5. So in the end, I will have like 30 number.
Okay.
Each number like is referring to how many items are in the new array, the filtered array. So it's just instead of just running check 5 and check 6, I will have 30 check. And each check will return an array. I will take the length of the array and put them inside a new array, which is the job of the map function. Mapping over a new, like from state to a new state, kind of. Okay? So here we will maintain this. Yeah, for loop is easy, but the problem with for loop, there's a lot of problems with for loops, a lot. Especially like now you don't see like really like kind of why you need functions, but it just when you practice and you will start like having tasks, it's super easy and it's just, for example, if you have a for loop, you will have the number I, and you will have access to the you say numbers and curly braces and 1 or 0 and I. So there is a lot of logic behind it. So mapping and the I will increment each iteration, and you need to make the condition true. Imagine this in really like complex example. It's like building something like Facebook or so with a lot of like messages and counting the messages and stuff. That's super complex. Exactly. More troubles, more mistakes, more implementation details. But with map, just run a function. It's not my.
Also, if you at some point in your work you will start building sort of a collection of such logical units, and then you just apply them to different types of data. So you have this collection of functions, you know exactly what they do, and then you apply them in the right situation. Whereas when you write a for loop, you have to write it always in that place with the name of those variables, and it has to fit exactly. And you have to write it over and over again. But if you have those functions, you just realize, okay, in this situation I want to do the filtering. I just use that function to filter arguments, and you're done.
Is there also a difference in rendering speed or processing speed?
Well, yeah, that's true.
So
Yeah.
If I have 10 different for loops on one page, or as opposed to 10 different.
Yeah, there is like performance like measurement, like you can try that, but it's not really important because JavaScript is really fast now.
Okay.
So it doesn't count like for JavaScript if you are using for loops or, well, it counts, but it counts if you are using like 3 millions or 4 millions, you will see small difference. But
Okay.
it's not really something because it's fast enough. Now we have really like high like CPUs like and RAMs. Like this computer has 16 GB of RAM, so you can load like billions of numbers in the memory. So we are not really into like this stage where we should think about numbers. Well, sometimes if you are programming for because I've watched a talk from Airtime, the building like devices. So they're building like the Chromecast, so they need to send like pictures over a really small machine and stuff. Well, their optimization count. Every bit, every number, every pixel, every color really count. But generally, it doesn't really count.
Okay.
So, and you can check after. You can, but it's really bad to, instead of focusing on getting the job done, trying to optimize really small stuff.
Yeah.
Get your job done, write code that works. After that, you can optimize. But don't optimize before having anything. You cannot say to your like business owner, "Oh, I was optimizing the code. I couldn't really deliver that feature." What? Optimizing what? Exactly. I don't care. Give me something I can see. Give me a web page. I don't care if it's fast or slow. So get the job done. After that, you can optimize like step by step. Okay. So now we will try to duplicate this code and run it over the numbers array instead of just like using the this one example. Okay. So we will use numbers.map. And map will give me a number. That's true. Number, which is 1, 2, and 30. And I will duplicate this code. So here, instead of running it over and accessing a specific element, I can just do this. And I will call it check n and check n here. Check n means check 1, check 2, just like a variation. Array n, so we can say var, and I will return actually here the array.length instead of console log. And here I will not return anything. I will just console.log numbers. So here it will return a new array. Map will return a new array. Const new array, and I will new array. Okay, but one thing, I'm calling numbers here, but I'm not calling the sum. So I will say I will create const sum function. This U is really tall. That's weird. And I will call sum function with the array. Okay. But I know I don't need really a console.log. I will need it after actually, but I don't need it now because I'm already using console.log inside here. Okay. Let's try and see if it's working or not. Probably it's not. Well, it's working. So we have like 1,500, 333, 250. Yeah. Yeah. There is 32. So probably because of.
I don't think. We have already 30 elements in the result.
What?
We already have 30 elements in the view and
Okay. Yeah, that's fair. But is it clear?
Yes.
Any questions? Are you sure? Don't be shy.
Now we need to play with the code.
Oh, yeah, for sure, for sure.
It's a good practice to use global variables inside.
What?
Good practice to use global variables inside the function.
I cannot really, like, it's really subjective. I cannot really say, like, this is the best practice every time. It's really depending on your case. Like, it depends, really.
But you're actually not really using global variables here. You're just using like a variable from the parent scope, which is inside another function. We are passing the 1,000 element array to it. Instead of it, you can just like just use it. You could just use it, but then you basically lose your ability to apply the function to a different array. Like if you leave it as an argument, then you can pass in any array that you want in future. If you refer to the global variable, then it's the function is fixed to that variable, and you cannot use it for anything else. It's best if you use it with an argument, because then you can apply it in different situations.
No. Of course. But just one thing, I will return it here. I will return new array, and I will console.log some function. I will just copy this. Oh, got it. So we can have it available outside if you want to play with it, for example. Because now this is why you should return something. The function should return something instead of doing like everything inside. So here, for example, we returned the check, and the check will return the filter. Imagine if if you had just like to console.log here, we couldn't really reuse the divisible factory here. If you could just like console.log. This is why it's better to return, and you just do your job and you return back to the caller of the function, and the caller of the function, if he wants to delete, print, it's up to him. So it's better to just like compute. And also the same thing here. We just return the new array. And the caller will display it or do something with it, play with it, filter it. It doesn't matter. Okay? Okay. Now let's say Kevin. No.
But sometimes you ask yourself, why it's useful? Why in life I would do this home? Sometimes. You know, like why I'm collecting numbers and do all this stuff.
It's not about collecting numbers. It's about we need the exercises.
Yeah, but
it could be like
I don't feel like
if it's faster, we could build like YouTube like kind of counter. But it will just take time to connect to the YouTube API and fetch videos. So instead of having these numbers, instead of having numbers here and generating numbers, we could do numbers equal get YouTube views. And here it would be like a promax inside it.
And did you hear that the task afterwards with the movies, did that make more sense to you?
I didn't do it.
But in principle, you feel
when you do
that's
something like in real world.
Yeah, because this exercise basically gives you the abstraction of it. You can apply what you learned here in this class to the movies, right? You filter over the movies with the right rating, and then you. So this is a preparation.
Exactly.
Which kind of tries to give you the idea in the smallest form, and then you apply it later to things that matter more.
Precisely. It's like driving a car or something. When you are really like seeing what you need to drive a car, so like I don't know, like or a bike or something, you need to learn some extra stuff, but you don't need exactly. You don't know what you will kind of be doing in the real world. But once you put the car on the track and you see that when you do this, it will accelerate and it will turn, and there is like stuff you need to avoid and you need stuff to respect. That's kind of useful. But doing this,
No.
But when you apply this in the proper context, you will see that, oh, I need this to return, so I don't really go straight because my job is there. You know, so you are using or composing the smallest stuff that you learn. Yeah, to do something more like this. It's the same thing here. You're learning how to map over a number or something, but you can use this to build Facebook or YouTube or Google because this is what they are like doing. Okay, so is it clear with the closures, scopes, something like that?
Getting clearer.
Nice. Yeah, that's the thing. It's like just like doing a step every day. It's not about now I understand everything. You will never achieve this. No one already like achieved this. Even if you build JavaScript, you cannot because it's evolving every day. Even the creator of JavaScript, he doesn't know a lot of stuff about JavaScript now, because like 20 years or something of development and Google and stuff are running JavaScript. So it's not really about saying I know everything now. You will never achieve this stage, never ever. But it's about like becoming closer every day and solving more problems and having clearer picture.
I would just say about this example, the nice thing of always sort of having a function, having an input, it does some transformation, then it returns. It allows you to chain sort of functions together. So in this example, you scroll up a little bit.
Of course.
Yeah, right there. So here, inside of that map, we kind of use 3 lines to get the results that we want. You could write all of that in one line because you can chain the outputs from the individual functions together.
Yeah. We can actually, when I was in when I broke my leg, actually I was in Amsterdam. I was in a conference there. It's a React conference, JavaScript conference, and there was a challenge by Amazon, the company Amazon, AWS, which is the cloud provider, subsection of Amazon, and you have an exercise and you need to solve it in like you use like less characters as possible. So that's kind of tricky, and it's not really important because why less characters? More characters, more spaces, so the code will be clean and stuff. But sometimes they just want to challenge you. So yeah.
It's like about reading code to go reading code.
Yeah,
I want to read code like reading line.
Yeah, yeah, exactly. Because you will kind of be reading code more than coding, I think.
Yeah.
That's, I think, more the professional work. Reading more code of your coworkers, the people you work with, than really writing code. So, what the next part?
Almost the break. What are the
promises?
You want to take over promises or? Okay. You want to keep me here? Okay, makes sense.
You're on the spotlight.
Yeah, you're on the spotlight.
Actually, I can go there. Like, I will go there actually. Ball.
Why it's not? Because what?
It's polished by birth. Is it? Polished by not resolved.
Nice. Okay.
Are we doing the break before promises or?
Yeah.
Do you want the break now? What do you think? Should take the break now and
Well, 10
stop.
minutes to the lunch break, so.
So yeah,
I don't
and
know
stop
if it
10
makes
minutes
sense to
before.
start.
We have 15 minutes. 10 minutes.
Okay, we will have the break now.
See what